Hey guys, so today I'm going to explain the difference between the Supremum and the Maximum. So before diving into the actual formal mathematical definitions, it's important that we can actually visualize something like this. So first, let's consider this mug. It's a really tall mug. All right, so suppose that someone wants to fill this mug up with like water, and they're a little weird, so they want to fill up the mug with as much water as possible without getting a single drop out. So like this drop, this is not allowed. So let's say that in the first pour, let's call him Jimmy. Let's say Jimmy pours up to 9.5 centimeters. And let's say that he's not satisfied with this. He wants more. So let's say he pours again. And he gets up to 9.9 centimeters. And let's say even here he's not happy. So he actually pours again. And somehow he gets 9.99999 centimeters. So since this cup is 10 centimeters, right? There's no maximum amount of water that he can actually pour. So he can keep adding droplets, tiny, arbitrarily small droplets, and get this number maybe to like 9.99999, as many nines as you want. But this number can keep getting bigger, but it'll never reach 10. So what I'm getting at here is that the maximum of this example is the actual height of the water that's attained, but the Supremum is the actual ceiling. So it's 10 centimeters. It's the height of the actual cup that is not attainable. So let's talk about the formal mathematical definitions here now. So let's talk about the max first. So the max of, let's consider a set S first. Consider a set S. So the max of this set, let's just call it M. And this is the same as saying that for M in this set, and for all X in the set, X is less than or equal to M. In other words, M is the maximum of S, which means that M lies in S and no element of S is larger. Now let's consider the Supremum. So you write it like this. Let's say that it's equal to L, and this is the same as saying for every single element X in S, X is less than or equal to L, and for all epsilon greater than 0, there is an X in S such that X is greater than L minus epsilon. So let's understand this second part first, because this is basically what we had in the example. This little tiny distance right here between 9.99999 and 10, this is epsilon. Hopefully you guys can see that. I tried. So what this is saying, X is greater than L minus epsilon, is saying that we can keep finding a height of the mug that we can pour some more water in, that it's closer and closer to this limit. And basically, the Supremum, you keep getting closer and closer to it, and you may or may not reach it. And that's just basically the difference. The maximum lies in the set, but the Supremum, it doesn't have to lie in the set. It could be outside of it. It could be just outside of it. It could be so close, but it doesn't have to be in the set. And that's the difference between the supremum and the maximum, guys. So thank you.